Discussing the interference of microwave. Interference of microwave can be used. Microwave can be used to conduct two-source interference experiment. Two-source interference experiment demonstration of wave physics. Demonstration of wave physics. Micro interference of microwave can be used to conduct two-source interference experiment for demonstrating interference of microwave. Microwave can be used to conduct two-source interference experiment for demonstration of wave physics. Microwave for two coherent sources of same frequency and phase overlap, they create an interference pattern characterized by alternating regions of constructive and destructive interference. A detector records microwave intensity and constructive and destructive interference point. Display a pattern that can be visualized on the screen through a recording device. Interference. Yeah, let's make a diagram. Microwave interference can be used to conduct interference of microwave. By discussing the interference of microwave interference, interference of microwave waves. Interference of microwave. A microwave can be used to conduct two-source interference. A microwave wave. A microwave can be used to conduct two-source interference experiment. A microwave can be used to conduct. A microwave can be used to conduct two-source a microwave can be used to conduct two-source interference two-source interference experiment two-source experiment for demonstration for demonstration of wave physics. WAVEPHYSIC physics. Wave physics. For wave physics, microwave from two coherent sources. Microwave from two coherent sources. Microwave from two coherent microwave from two coherent sources. From two coherent sources. Coherent source. Microwave from two coherent. A microwave can be used to conduct two-source interference experiment for demonstration of wave physics. Microwave for two coherent sources. SOURC source of the same frequency, FREQUENCY, frequency and physics, and phase, phase. Microwave from two coherent sources of same frequency and phase overlap. They create an interference pattern, PATTERN, characterized characterized by alternating region. Microwave can be conduct two-source interference from the demonstration of wave physics. Microwave from two coherent sources of same frequency and phase overlap. They can create interference pattern characterized by alternating region. Region of constructive, and destructive interference. A microwave can be used to conduct two-source interference. A microwave can be used to conduct two-source interference. A microwave can be used to conduct two-source interference experiment for demonstrating demonstration of wave physics. Microwave from two coherent sources of same frequency and phase overlap, creating an interference pattern characterized by the alternating region of constructive and destructive interference. They create an interference pattern to characterized by alternating region and constructive and destructive interference. Microwave can be used to conduct two-source interference from the demonstrating of wave physics. Microwave can be used to conduct two-source interference experiment from demonstration of wave physics. Microwave can be used to conduct two-source interference from demonstration of wave physics. Microwave can be used to conduct two-source interference experiment from demonstration of wave physics. Microwave can be used to conduct two-source interference two-source interference for demonstration of wave physics. Microwave can be used to microwave can be interference of microwave can be used to conduct interference source. Microwave can be used to conduct two-source interference experiment for demonstration of wave physics. Microwave from two coherent source with same frequency, two coherent source of same frequency and phase overlap, frequency and phase overlap. They create an interference. Microwave can be used to conduct two-source interference for experiment demonstration of wave physics. Microwave can be used for interference. Can be used to conduct two-source experiment. Two-source interference. Microwave can be used to conduct two-source interference experiment for demonstration of wave physics. Microwave for two coherent sources with same frequency and phase overlap, they create an interference pattern characterized by alternating region of constructive and destructive interference. Microwave can be used to conduct two-source interference experiment. Microwave can be used to conduct two-source two-source interference experiment for demonstration of wave physics. Microwave from two coherent sources have same frequency and phase overlap. They can interfere. They create an interference pattern characterized by alternating region of constructive and destructive interference. A detector record microwave intensity experiment from the demonstration of wave physics. Microwave from two coherent sources of same frequency and phase overlap. They create an interference pattern characterized by alternating region of constructive and destructive interference. Microwave can be used to conduct two-source interference experiment from demonstration of wave physics. Microwave from two coherent source of same frequency and phase overlap. They create an interference pattern characterized by alternating region of constructive and destructive interference. They create an interference pattern characterized characterized by alternating region of constructive and destructive interference. They create an interference pattern characterized by alternating region of constructive and destructive interference. They create an interference pattern characterized by alternating region. They create an interference pattern characterized by alternating region of constructive and destructive interference. Are used to conduct two-source interference experiment for demonstration of wave physics. Microwave from two sources two coherent sources with same frequency and phase overlap. They create an interference pattern characterized by alternating region of constructive and destructive interference. A director region microwave. A director region microwave. A director region microwave. A detector record microwave intensity at constructive and destructive interference point, displaying pattern that can be visualized on the screen through recording device. A detector records record. A detector records microwave. A detector records microwave. A detector records microwave intensity. A detector records microwave intensity. Microwave. A detector records microwave intensity. A microwave detector records intensity at constructive and destructive and a detector record microwave intensity at constructive and destructive interference point in interference point. A detector record microwave intensity at constructive and destructive interference point, displaying a pattern displaying a detector record microwave intensity at constructive and destructive interference point, displaying a pattern pattern that can be visualized visualized on a screen or through through a recording device. A detector record microwave intensity at constructive and destructive interference point, displaying pattern can be visualized on the screen through a recording device. Microwave can be used to conduct two coherent source interference experiment demonstration. Microwave can be used to conduct two source interference experiment for demonstration of wave physics. Microwave can be used to conduct two source interference experiment for demonstration of wave physics. Microwave for two coherent sources of same frequency and phase overlap. They create an interference pattern characterized by alternating region of constructive and destructive interference. A detector recording microwave intensity at constructive and destructive interference point, displaying a pattern that can be visualized on the screen through recording device. Displaying pattern that can be visualized through recording device. Blah blah blah. experimental setup a microwave can experimental setup experimental setup a microwave can you write the microwave somewhere? Yeah, let's try. तो एक्सपेरिमेंट स्पेलिंग क्या मुझे भी नहीं आती. Fioran sources to find sources of the overlap. देख रहे हैं देख रहे हैं I don't know. They create an interference pattern interference pattern by an alternating region of constructive and destructive DES यहाँ तक हो गया. A detector a detector can be used to record in intensity microwave microwave intensity on microwave intensity on board constructive and destructive interference point destructive interference point comma displaying a pattern that can be visualized by a screen through a record recording device DEVICE recording device. That experiment. I don't know. Experiment. Microwave experiment involve a transmitter implementing a microwave experiment setup. A microwave experiment involve a transmitter emitting microwave towards two slides. A microwave experiment involve a transmitter emitting microwave towards two slides, causing wave interference. The receiver measures the intensity of the receiver measures the intensity of the resulting microwave, placing at the different distance and angle for the slides. A microwave experiment involves a transmitter emit microwave toward two slides. A microwave experiment involves transmitter emitting microwave towards two slides. A microwave experiment involves a transmitter emitting microwave towards two slides. A microwave experiment involves a microwave experiment or transmitter emitting microwave towards two slides. A microwave experiment involves a transmitter emitting microwave towards two slides. A microwave experiment involves a transmitter emitting microwave towards two slides. A microwave experiment involves a transmitter emitting microwave towards two slides, causing microwave interference. A microwave experiment involve a transmitter emitting microwave towards two slides, causing wave interference. The receiver measures the intensity of resulting microwave, placing the different angle and placing different distance and angle from the slides. A microwave experiment involved IMICRO microwave experiment involve INVOLV is involve a transmitter emitting emitting microwave towards microwave. A microwave experiment involve a transmitter emitting microwave towards two slides causing interference waves पहले लिख ले बाद में लिख ले कोई फर्क नहीं पड़ता. A microwave experiment involved transmitter emitting microwave toward two slides causing wave interference. The interference. A microwave experiment involved a transmitter emitting a microwave experiment involved a transmitter emitting microwave towards two slides causing wave interference. The receiver measures the intensity of the resulting wave of the resulting microwave. The receiver measures the intensity of resulting microwave waves wave placed at a different place at a different distance and angle from the slide. Different distance and angle from the slides. A microwave experiment involved a transmitter emitting microwave towards light causing a wave interference. The receiver measured the intensity of the resulting microwave. The receiver measured the intensity of resulting microwave wave at a different distance angle from the slides. A microwave experiment involved transmitter emitting microwave from towards two slides causing wave interference. The receiver measures the intensity of resulting microwave placing at different distance and angle from the slide. A microwave experiment. A microwave experiment involves क्या आगे क्या आता है मुझे खुद भी नहीं पता. A microwave experiment involves transmitter transmitter to emit microwave towards I don't know. Towards I really don't know. Towards to slide causing wave interference आगे क्या आता है. I really don't know. The receiver receiver does measure the intensity of the measure the intensity of microwave resulting microwave resulting microwave wave placing place at different distance and angle from slide angle from the slide different angle from the slide. A microwave experiment involved transmitter emitting microwave towards the slide causing wave interference. The receiver measured the intensity of resulting microwave placed at a different distance and angle from the slide. The experiment data help in calculation microwave wavelength. The experimental data helps in calculating microwave wavelength. Experiment data helps in calculate microwave wavelength. The experiment data helps in calculating microwave wavelength using wave superposition and interference principle to determine maximum and minimum intensity distance. Okay. Experiment data helps calculate. Experiment data helps calculate the microwave wavelength. Calculating my helps microwave wavelength using microwave superposition using microwave superposition and interference principle to determine maximum and minimum intensity distance. These experiments not only demonstrate the wave nature of microwave but also practical implication for intense understanding microwave interference is crucial in design microwave communication system to avoid signal loss due to destructive interference. Microwave interference principles are similar to sound wave, water, and quantum mechanics, where particles exhibit wave-like behavior. Two coherent sources, two source interference experiment with microwave two source experiment data helps to calculate microwave length. Experiment data helps calculate microwave length. Data helps microwave experiment data helps to calculate microwave wavelength using superposition and interference principle demonstrate interference principle to intensity distance. These experiment not only demonstrate the wave nature of microwave but also having practical implication for intensity. For instance, understanding microwave interference is crucial in design microwave communication system to avoid signal loss due to destructive interference. Experiment data help in calculating microwave length. Experimental data help in calculating microwave wavelength using wave superposition and interference principle to determine experiment data helps in calculating microwave wavelength. Experimental data helps in calculating microwave wavelength using wave superposition and interference principle to determine maximum and minimum intensity distance. Experiment data helps in calculating microwave wavelength. Experiment data helps in microwave wavelength. Experiment data helps in calculating microwave wavelength. Experimental 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 data helps in calculating microwave wavelength using microwave superposition and interference principle to determine maximum and minimum intensity. Experimental data helps to calculate experimental data help in calculating experimental data help in calculating microwave wavelength using Experimental data help in calculating microwave wavelength using wave superposition, SUPER, superposition, superposition, and interference principle and interference principle, PRINCIPLE, well, to determine maximum and minimum intensity distance. Experiment data help in calculating microwave wavelength using wave superposition and interference position to determine maximum and minimum maximum MAXIMUM and minimum MINIMUM, maximum and minimum intensity, maximum intensity distance. Experiment data help in calculating microwave wavelength. 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 Experiment data helps in calculating microwave wavelength using wave superposition and interference principle to determine maximum minima intensity distance. Intensity in the experiment data helps in calculating experimental data helps in calculating microwave wavelength using wave superposition and interference principle to determine maximum minimum intensity distance. Wave superposition and interference principle of determine maximum minimum intensity distance. These experiment This experiment not only demonstrate the natural. This experiment not only demonstrate the wave nature of microwave of ICROWAVE as wave also, but also have practical practical implication for instantaneous. The experiment not only demonstrates the wave nature of wave. This not only demonstrates the wave nature of microwave, but also the practical implication for instantaneous understanding microwave. This experiment not only demonstrates the wave nature of microwave, but also having a practical implication. This experiment not only demonstrates wave nature of microwave, but practical implication for instance, understanding micro-interference is crucial in designing microwave communication system to avoid signal loss due to destructive interference. This experiment not only demonstrates This experiment not only demonstrates the wave nature of wave. This experiment not only demonstrates the wave nature of microwave, but also practical implication. This experiment not only demonstrates the wave nature of microwave, but also practical implication. For instantaneous understanding microwave. Understanding microwave interference is crucial. Understanding microwave wave interference is crucial. Crucial for designing designing microwave communication system. Microwave communication system, communication system, microwave communication system. This experiment not only demonstrates the wave nature of microwave, but also having practical implication. For instance, understanding microwave interference is crucial for designing microwave communication system to avoid loss signal loss signal lost due to interference due to destructive interference. For instantaneous understanding microwave interference is crucial. Understanding microwave interference is crucial. This experiment not only demonstrates the microwave. This experiment not only demonstrates the wave nature of microwave, but also practical implication. For instance, understanding microwave interference is crucial for designing microwave communication system to avoid signal loss due to destructive interference. This experiment not only demonstrate wave nature of microwave, but also practical implication. For instance, understanding microwave interference is crucial in designing microwave. For instance, understanding microwave interference design is crucial in designing microwave communication system to avoid signal loss due to destructive interference. Microwave interference principles are similar to sound wave quantum mechanics. Similar to sound water quantum mechanics, these particles exhibit wave-like behavior. Two source interference experiments with microwave offer valuable insights into wave phenomena that govern various aspects of physical world. Microwave interference principle similar to sound wave in water sound, similar to sound water quantum mechanics, similar to sound water quantum mechanics, similar to sound water quantum mechanics. Alright, these two are last, then chapter finish. Microwave interference principle are similar to sound wave, sound water, and quantum mechanics. Quantum wave, which are where particle exhibit wave-like behavior, where particle exhibit wave-like behavior. Principle 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 is similar to similar to sound water and quantum mechanics, and QUANTM quantum mechanics, MECHANICS mechanics, where particles exhibit exhibit wave behavior, BEHAVIOUR wave-like behavior. Two-source interference experiment with microwave offer valuable insight into wave phenomena that govern various aspects of physical world. Microwave interference particle and microwave interference physics principle are similar to sound, water, and quantum mechanics, where particles exhibit wave-like behavior. Two-source interference experiment with microwave offer valuable insight into wave phenomena that govern various aspects of physical world. Two-source interference experiment with microwave offer microwave offer insight wave phenomena inside wave phenomena, inside wave phenomena. Inside wave phenomena आगे कहता है and inside wave phenomena and govern various aspect of physical world